This is also new concept, that is polymers. We will see the what is polymers and what are the different types of polymers and how it will be used for different applications and how the applicable will be satisfied for different properties and controlling and how the strengths will be improved. Course under the advanced materials presented by Dr. Bhajan Sheikh, Professor of Ramchandra College of Engineering and developed by Jawaharlal Nehru Technological University, Kakinada. Coming to polymers, we will see what is the definition and how it will be called as polymers. Generally, polymers, what is polymer? How it will be named as polymer? The term polymer is derived from the two Greek words. What is the two Greek words? The Greek words are two types, that is poly meaning many and meros meaning parts or units. Thus, polymers are composed of large number of repeating units, small molecules called monomers. Here, you have to understand how these polymers are composed and what is the different molecules involved, and the molecules will be called as monomers. And these monomers are joined together end to end in polymerization reaction in order to get the structure, clear picture or clear structure of the polymer materials. The polymer made up of thousands of monomers joined together to form a large amount of colloidal dimension called macromolecule. This is the concept behind involved in these polymers. This polymer takes a major role for the unique characteristics of the polymer is that each molecule is either a long chain or a network of repeating units all covalently bonded together. And coming to the polymers having different conditions satisfying what are the different fundamentals involved in this polymer technology and what are the different classifications or types of polymers. That is thermoplastic polymers, thermosetting polymers, elastomers. These three types takes a major role in these polymers. And we will see how the processing of polymers also. First of all, polymers is having it is a compound consists of long chain molecules. Already we know that what is the molecules and how the molecules formation it will be called as monomers and how these monomers will be considered in order to have the macromolecule and how the characterization taken place in order to have the final structure of polymers. Uh, Even millions of years that is called as thousands and even millions of years is called a single polymer molecule. And also it is the for most of the polymers based on carbon and considered for the organic chemicals. And these are the engineering materials, these are the three types. Polymers are separated by the plastics and rubbers. These are the three types we have seen. Elastomers also called as rubbers. Already you know the thermoplastic polymers and thermosetting polymers or classification involved in polymers. Elastomer is called as rubbers. And what is thermoplastic polymers? How it will be called? And it is thermoplastic polymers. Its main thing involved in the solid materials at room temperature, but viscous liquids when heated to temperatures of only a few hundred degrees. And these thermosetting polymers characteristics allows them to be easily and economically shaped into products. And the thermoplastics can be subjected by heating the cooling cycles repeatedly without significant degradation. And these thermosetting polymers, thermosets which cannot tolerate repeated heating cycles are thermoplastics. When initially heated, they soften and flow for molding. But elevated temperatures are also to produce a chemical reaction that hardens the material into an infusible solid. If reheated, thermosets degrade and characteristics rather than soften. And coming to elastomers, elastomers takes a major role for a they exhibit the extreme elastic and it is subjected to low mechanical stress. This is the main advantages involved in this elastomers. It is also known as rubber, and these elastomers can be stretched by a factor of 10 in completing the recovery of the original shape. It's having the properties and are quite different from the thermosets. It is interlinked with related to thermosets, elastomers, and they are share a similar molecular structure that is different from the thermoplastics. Coming to market share, this is very important for how these polymers takes a major role for current conditions and how the market shares will evolve for these different types of polymers and how it will be helpful. In this market share, thermoplastics are commercially the most important of the three types, constituting around 70% of the tonnage of all synthetic polymers produced. And coming to thermosets and elastomers share the remaining 30% about evenly with a single edge for the farmer. In this market share, the volumetric basis current annual usage of polymers exceeds that of metals. And coming to different examples of the polymers, thermoplastics examples related to polymers, polyethylene, polyvinyl chloride, polypropylene, polystyrene, and nylon. And coming to thermosets, examples are phenolics, epoxy, and certain polyesters. And coming to elastomers or rubbers, it is a natural rubber, vulcanite, and synthetic rubbers which exceed the tonnage of the natural rubber. These are the three types and three types related, different examples related to polymers. And what is the reason behind why polymers are important? For any material, there is a very important and how improving conditions satisfy. Generally, plastics can be formed by molding into intricate part shapes, usually with no further processing required. It's very compatible with net shape processing and how on a volumetric basis polymers are competitive with metals. Generally, it requires less energy to produce than metals. Certain plastics are translucent and are transparent, which makes them competitive with glass in some applications. Generally, for these polymers, general properties of polymers having the low density related to metals and ceramics, it's having good strength to weight ratios and how high corrosion resistance, having low electrical and thermal conductivity. These are the general properties behind the polymers. Depending upon the properties only, we can manufacture for any structures. And coming to limitations of the polymers for different engineering materials, it shows the low strength related to metals and ceramics, the low modulus of elasticity related to stiffness. Service temperatures are limited to only a few hundred degrees. Viscoelastic properties which can be distinct limitation in load-bearing applications. Some polymers degrade when subjected to sunlight and other forms of radiation. And coming to synthesis of the polymers, generally it's having the all polymers within engineering. It is synthetic because these all will be processed in chemical base. These polymers are synthesized by joining many small molecules together into very large molecules that will be called as macromolecules. That process in long chain or we call as chain-like structure. Generally, we know that small units called as monomers, that organic molecules such as ethylene. Ethylene is a C2H4. This shows the synthesis of the polymers. You can observe this is the clear picture how the synthesis of polyethylene from ethylene monomers involved. You can observe the structure of the ethylene that is an ethylene monomer series. And second figure shows the polyethylene of chain length and 2B shows the concise notation for depicting the polymer structure of chain length. This is the basic structures related to polyethylene, synthesis of polyethylene structure. You can observe the image, you can understand the example of synthesis of polyethylene. And coming to the polymerization, polymerization is a chemical process. Because the synthesis of the polymers can be occur either two methods. That is related to addition of polymerization, step polymerization. In this production of given polymer is generally associated with one method or the other. And coming to the addition of the polymerization, having the process exemplified with respect to polyethylene with carbon atoms, ethylene monomers are introduced and how the connections, how it will be called as initiator. And these are the model of additions. You can observe the structures, how the monomers. First figure shows the more. These all three figures show the model of addition of chain polymerization. First is the initiation, how the monomers will be interconnected with different molecules. Already we know that what is molecule, what is monomers, what is macromolecules. We have seen the clear structure. And second figure shows the rapid addition of the monomers. And third figure shows the resulting of long chain polymer molecules with NMR termination of the reactions. This concept shows the what is monomers and mers and how it will be manufacturing the polymers behind the concept.